You place a record of your favorite album on a gramophone. Out of curiosity, you place two dots on the record, one in the inner radius and another on the outer radius. You also place a yellow marking on the player to act like the finish line because you wanted to know which of the two dots would reach the finish line first once the record started playing. You know that this is the same problem as the red ladybug and the green bug in the previous video. So you guess that since the outer dot would be moving much faster or would have a higher tangential speed, it would reach the finish line first. But upon careful observing, you saw that both of the dots reached the finish line at the same time. And you started to wonder why this is so. If you found yourself a little bit confused, you probably don't know the difference between tangential speed and rotational speed. When you want to know how fast an object is covering a circular distance, that's tangential speed. But if you want to know how many rotations an object is doing over time, you are getting its rotational speed or velocity. So, while the outer dot has higher tangential speed than the inner dot, both of them rotated only once during the same period. Hence, their rotational speed is the same, and they would reach the finish line at the same time. Rotational speed and tangential speed is rotated to each other using the formula below. Tangential speed is equal to the radius times the rotational speed. V is equal to R times omega. The unit of rotational speed is stated in RPM or revolutions per minute. The seconds hand of a wall clock, shown in red here, has a rotational speed of 1 RPM. This is because it takes it 1 minute or 60 seconds to make one full cycle around the face of the clock. The drill which dentists use to perform various operations, such as removing decayed parts of a tooth, has a rotational speed of up to 800,000 RPM. Many disc recording media, like a gramophone record, has to be rotated at a specific speed to make the stored sound information audible to us. Rotational speed is also referred to as angular speed or velocity. This is because when an object rotates, the distance it covered or swept can be expressed in angles. For example, if 15 seconds have passed, that means the second hand of a clock has rotated by 90 degrees. If 30 seconds have passed, it has rotated by 180 degrees. Angular rotation is also expressed in terms of radians per second, or rad per second. A complete revolution of 360 degrees is equal to 2 pi radians. If half a revolution was made, that is 180 degrees. In terms of radians, that is pi radians. Here's a simple calculation showing how you can convert revolution to radians. If we have a bicycle wheel that rotated 4.5 revolutions, its rotation in radians is equal to 28.3 rads. In summary, angular velocity refers to the number of rotation or revolution an object makes over time. Angular velocity can be expressed in terms of revolution per minute or rad per second. The linear speed of an object is related to angular velocity by means of the equation v is equal to r times omega.